Okay, 8.4 is the last section in Chapter 8, and we're going to be using another mode on our calculator today. So these are called plane curves and parametric equations. Plane curves and parametric equations. Okay, so we're going to be graphing these parametric equations today, and we're going to be expressing them in rectangular form by doing a process called eliminating the parameter. And all parametric equations is a way to describe a curve. What makes them special is they don't just show the shape of a curve, they also show you how it's being graphed. So that's your direction of motion. And then like you guys saw earlier, they are functions of an independent variable t. And that is going to commonly represent time. Okay, so this is taken from your textbook, the information box on parametric equations. So if you have f and g that are functions defined on an interval, they are going to create a set of points. Okay, the set of points are formed by plugging in t. F of t is equivalent to your x, g of t is equivalent to your y. Okay, and then if your value of t is in the interval, those are parametric equations with a parameter t. Okay, so t is called the parameter. And we're going to read through this example together on page 564, and we're going to graph it on our calculator. So you are going to have to switch your mode. Right? You can switch your mode to parametric mode. And we're going to be graphing example 1. Okay, so it says to read through this and then switch your mode. And what you're going to answer is, did your graph look the same as the one in the text? And if not, how can we make an adjustment? Okay, so this is the information box that we just went over. And then in example 1, we have the parametric equations, x equals t squared minus 3t, and y equals t minus 1. Okay, and then when you guys switch your mode, you guys are probably in polar mode. When you go to your mode, if you're in polar, we're just going to arrow it over to parametric. Okay, or some of you just have the PAR, that's fine. And then when you hit y equals, you're going to see you have an x and a y. Okay, so your x1 is going to be t squared minus 3t. So when you hit your variable button, you're going to see that. Okay, and then we have t minus 1. Okay, so go ahead and graph yours, and then I want you to write if that looks like what we have here in example 1. Okay, so look at your example 1 right there, and then just say yes or no. it doesn't look like the one in the picture. We can all agree on that, right? All right. All right, so most of yours looks like this if you didn't do any adjustments. Okay, if you look at the picture here, you have a table that has values of t. Then you have your x and your y. So if you want to see the full shape, you have to make sure that you have the right window. So if you go into your window, most of you probably have the T min 0 and the T max of 6.28. Do you guys know why you have that? It's to 2 pi. So it's the same thing as we had for theta. So now we're just going to change it so that the T min is -2. Okay, we'll put the max of 5. And then your step doesn't really matter as much. Okay, and then you should be able to see the full curve. The calculator here. Okay. All right, so then just go ahead and fill out that question. Okay, so did your graph look the same? And then what did you need to adjust? Okay, so what specifically did we adjust in the window? Okay, so you should have something here that says no because you have to adjust the t values. Okay, so you have to adjust the value of t. All right, and then in example 1, you are given a pair of parametric equations. You're going to sketch the curve. And then we are going to find a rectangular coordinate equation by eliminating the parameter. Okay, and then we are going to use 5 points for the next one, but for this one, they give us a value of t, and so we're going to graph more than that so that it fits our scale. Okay, so when you're plotting the points via the table, notice here that this says -3 to 3. Okay, so your values of t are going to be -3, -2, -1, 0, 1, 2, 3. And then we're going to find our x and our y. Okay, and you can use your calculator to do this. With the y's, you have a really simple linear graph, t minus 3. So if you plug in -3, -3 minus 3 is going to give you what? -6. If you plug in -2, you get -5. Okay, so for this one, it's just linear, right? Okay, and then for your x, we're just going to go back to our y equals. Okay, and then if you go to your table, and if you have a bunch of decimals in there, that's because the last time you did this, you were in polar form. right? So if you want it to match what we have here, do your table start at -3? Make the change in the table by 1. Okay, so then when you go to your table, you're going to be able to have those coordinating values. Okay, so you get 30, 18, 8, 0, -6, -10, -12. Okay, when you plot the points, you are only going to plot your x and your y. Okay, so every point that you're plotting is an xy coordinate. Okay, so when you plot 30, -6 on the graph, you are going to call it t sub -3. When you plot 18, -5, we're going to label that t sub -2. Okay, so when this is label points on the graph, you are just going to label them with the t sub 3, t sub 2, t sub 1. And then as you're plotting out your paper, normally you don't have the confines of this, right, on your graph sheet. So really you could do whatever you wanted when you're doing this on your homework. But if I want to go out to 30 and then -12, I'm going to have to pick a scale. For y's, you're just to -6, so okay, we can go by 1s on the y's. Oh, I should have counted with my x's to make sure that I had these the right way. Okay, so let's determine what we're going to scale by. Okay, and then once you've determined your scale, because you do have to go to 30, okay, so what did you guys decide for your scale? 4 by 5. I might go by 4s. Okay, and then once you've plotted your points, go ahead and graph that on your calculator so you can see what the shape is. And then you can connect your points together. Okay, and then when you graph them, you can see that you are going to connect them with a curve here. Okay, and then your window, again, if you want it to match what you have from -3 to 3, okay, it will show you that curve. And then just like we saw on the opening slide today, we're going to add those arrows. So remember, the nice thing about parametric equations is it doesn't just show you the curve. And that doesn't look as good as my other one. I'm still going to put the arrows in. Okay, so then we're just going to put the arrows in to show the direction. I'm going to show you this one because I did a beautiful job on connecting those three. Okay, so you're including your arrows to show how the curve is being traced. Okay, so that's what makes the parametric equation special. Can you wait until after I have to do just the second part? Okay, so when you eliminate the parameter, remember we talked about already in our information box that the parameter is t. So when you're eliminating the parameter, you are eliminating t from the equation. Sorry. Okay, so this is the process of finding your rectangular equation that represents the given parametric equation, but you are eliminating t. This is also going to help you identify the shape of your curve. Okay, or you can verify that it is the correct equation for that shape. Okay, so if you had a parabola opening upward, we know we'd have y equals x squared plus some value. Okay, and we're going to see a couple different types of shapes today. So the first thing we're going to do is just solve for t in the simplest equation given. Sometimes that's subjective. Okay, sometimes it doesn't matter which one you solve for. And then you're going to use substitution. Okay, so from the first page, x is t squared minus 7t. And y is t minus 3. Okay, so Toby, what's going to be the simpler equation to solve for? Yeah, so we're going to do y equals t minus 3, and we're going to solve that for t. Okay, so we just have to move everything over to one side. Okay, so Jackson, let me know what you get for t when you solve that. So what are you doing with the 3? That's going to be part of it. right? So if you're solving for t, what are you doing with the minus 3? Yeah, you just add it to y. Yep, so y plus 3. Okay, now for substitution, okay, we have to take that equation, and then, John, do you know what we're going to do with that equation? Yep, 2. No, we're going to plug it in for t. We're going to plug it in for t, but where are we going to plug it in? Don't listen to other people. Okay, so when you're doing substitution, you take one equation and you solve it for t, and then you have to take this and you plug it into the other equation. So you're going to plug it in for t into x equals t squared minus 7t. Okay, so I want you to simplify that. Is that what you meant by it? All right, so once you expand that, Jack, will you let me know what you get when you expand it?
I broke it down as y squared plus 6y plus 9 minus 7y minus 21.
Nice.
Go by that to y squared minus y minus 1.
Great. Now this looks like a quadratic, but with one difference. What is that difference? The what? Did you say 12 minus 12? Is that what you said? Oh, thanks. I was like, what? Thank you. I was like, the minus 12 is not different. Okay, so how is this different than most of the parabola equations that we see? What? I really just couldn't hear you. Yeah, the variables are switched, right? So it's x equals instead of y equals. Okay, do you guys know what that means for the parabola? Yeah, it's going to be sideways. So really up to this point, you guys don't study conic sections. If you go to Calc 2, you will study different types of parabolas, so ones that open to the left or the right. But this just means the parabola is going to open to the right because your a value is positive. We actually used to do a little bit of that in Algebra 2 Honors, but we got a new textbook. Okay, and then when you're doing this, now that you've seen that, you can identify what type of parabola it is. So any parabola that opens to the side are going to have that form. Okay, you can still see in this section like the y equals x squared, but this is going to be x equals ay squared plus by plus c. Okay, and then if a is positive, it goes to the right. If a is negative, it goes to the left. All right, and then for b, we have cosine and sine back again, and we're going from 0 to pi. So when you are setting up your table for x and y, Okay, this is where I want you to at least have 5 points. We can do this just like we did our graphing for trig functions. If I go from 0 to pi, what's halfway? Pi over 2, and halfway between there? Pi over 4. So we're going by pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, so we're going to use the unit circle to help us evaluate here. All right, so even if you don't have your calculator, that's okay. You don't need it for this. Okay, so if you plug in 0, remember, what's the point at 0? What's your point? That'll be, 1, 0, sorry. Yep, and then let's actually just do all the points. At pi over 4, what's your point? Root 2 over 2, root 2 over 2. Okay, at pi over 2, 0, 1. 3 pi over 4.
Negative 2 over 2.
Yeah, nice. And then pi, negative 1, 0. Okay, good. So remember, x is cosine, and then y is going to be your sine. Okay, so if you plug in 0, 0 times 2, 0. Okay, 2 times 1, 2. When you plug this in, what's 2 times root 2 over 2? Root 2, yep. All right, so fill the rest of that in. I'll ask you guys to help me. And then we're going to write out our points and we'll graph those. And if any of you have your course requests that you need me to sign, I know those are due today, feel free to just have them on your desk and I'll make sure I sign them.
Oh yeah, okay. Getting good news. It's got so dirty so fast. So excited. Jude, we should grab a box of tissues. I'm going back to the office.
Oh, this is this one, yeah. Okay, so pi over 2, Spencer, what'd you get for these two?
I got 2, 0.
Great. Okay, and then Kate, what'd you get for these? Other one. Root 2 and then negative root 2. Yep. Okay, and then Andrew, what'd you get for pi? Negative 2 and 0. Yep, this one will be 0. So the negative 1 will go with your cosine, and then your 0 will go here. Okay, and then we're going to graph these. And so your points are going to be t sub 0, t sub pi over 4. So it's your t value here. That's the little subscript. And then you have the 3 pi over 4. And then t sub pi. Okay, so you have 0, 2, and then it's a lot easier to graph root 2 as a decimal. So, Emily, will you let me know what that's going to be? Yep, so 1.4, 1.4, 2, 0, 1.4, negative 1.4, and then 0, negative 2. Okay, so let's go ahead and I'm going to scale mine by a half since I have these 1.4s here. All right, so we have 0, 2, that's our t sub 0. And then 1.4 is almost going to be there to that line. Do you guys know how you're supposed to connect those, what shape it's going to be? Yeah, it's half of a circle. Do you guys know why it's only half? Yeah, your t value is 0 to pi, and that is half of a circle. So if it was to 2 pi, you get to see the full thing. Which means when you eliminate the parameter, you should have the equation of a circle, okay, because it is half of a circle. Okay, so in the first one, we solved for t and we did substitution. Okay, if we're solving for t in this thing, we'd have to use the sign inverses and that would get kind of messy. So we are going to use something else. Something maybe you thought you were done with, but you are not. You are going to use your trig identities. What's our favorite trig identity? Yeah, the sine squared plus the cosine squared. So we're going to write out with the variable t. Sine squared of t plus cosine squared of t. Okay, and then what we're going to do is we're going to solve each of these for the sine of t and the cosine of t. So instead of just solving for t, you're solving for the sine of t. And then we'll do substitution. Okay, so we have x equals 2 sine of t. So to get the sine of t by itself, all we have to do is what? Divide by 2. So divide by 2, divide by 2. So x over 2 equals the sine of t. Okay, so go ahead and write out what the cosine of t is going to be equal to, and then think about how we're going to do that substitution. Okay, so Zarish, what did you get for the cosine of t? What does the cosine of t equal? Yep. Now there's 2 ways you can think about this next step of substitution. You're going to take those and you're going to substitute them into the ID. Okay, and simplify. So one way you can think of this is if you have the sine of t and this is the sine squared, you can just take that value and you can square it, right? The sine squared, and then the sine is x over 2. So you could write it like that. And do the same thing with the cosine squared. So if you have y over 2, and then square it. Or if you guys want to simplify it before you plug it in, you can. So if this is just the sine of t and you have the sine squared of t, if you just want to square both sides and then plug it in, you can. So if you square this, you get x squared over 4. This is sine squared, and then you could just plug in x squared over 4. Okay, so you can simplify first or you can simplify second. Thanks. And then we just put that on the cart back there. We just put it on the cart back there. Okay, now we know this is half of a circle and this should be the equation of a circle. Okay, it doesn't look exactly like one yet, but what can we do to both sides so it does look like the equation of a circle? Yeah, just multiply both sides by 4. So when you do that, you're going to distribute. Those will cancel. You'll have x squared plus y squared equals 4. So this is the equation of a circle where the center is 0, 0, and the radius is 2. Okay, so for 1 and 2, I just want you to eliminate the parameter. You don't have to graph it. Okay, I'm going to give you some time to do number 1. There is more than one way to do that. Okay, so for number 1, you can pick which equation you think is simpler. We're going to do them both ways, so you choose. All right, how many of us are starting with this? Y equals 1 minus t. Thumbs up for that one. Okay, how many of you are doing the x equals root t? Okay, all right, so if you chose this one and you're solving for t, you have to add t to this side, subtract y, and then in step 2, when you plug that in, this is step 1, this is step 2, okay, you get x equals the square root of 1 minus y. Okay, you are going to want to solve this for y. So to do that, you can multiply, or not multiply, but square both sides. So you have x squared is equal to 1 minus y. And then again, you'd want to add y to this side, but you'd want to subtract x squared. Okay, you can leave it like that, or you can write the x squared first. Okay, so because you have x squared, this is a parabola, and which way does this open? Yeah, because you have the x squared instead of the y squared this time. Okay, if you chose this method, when you solve for t, you end up squaring at this step. Okay, so this is step 1, getting t by itself. Step 2 is plugging it into the other equation, y equals 1 minus x squared. Okay, so either way, you're going to get the same one. So there are some of them where you can choose your favorite. Okay, for number 2, though, we're going to have to use our trig IDs. Okay, so write out the trig ID that's going to relate the secant and the tangent. And it's okay if you don't remember that off the top of your head. Remember, you can just divide to get there. What would I divide this by to get a tangent? Cosine. Because sine squared over cosine squared is tangent squared. Cosine over itself. I put x, I'm going to change it to t. So cosine divided by cosine would be 1, and then 1 over cosine, the secant. Okay, now this one, you don't have anything to solve for. You just have x already equal to the secant. So if it's the secant squared, what could you do to both sides? What would secant squared equal? So if you square the secant, you're going to get x squared. Okay, so then in place of secant, we're going to place x squared. What are we going to plug in for tangent squared? Y squared. Okay, now this is an equation you're not familiar with, so it's okay that you don't know how to move this without me explaining that to you. But whenever you have an x squared and a y squared, when they're both squared, you want to move them both to one side of the equation. Okay, so when you're doing those on your own, I'm not going to be picky about the form that you leave it in. Okay, I just want you to have your values substituted. Okay, so for 8.4, this one is not a mandatory section, but you are going to have some graphs on there. So if you need some graph paper, I put my bin out if you would like a piece. You only need one. It's a short assignment. Okay, so if you're looking for a way to boost your grade, doing the non-mandatory homeworks will do that for you. Okay, and then we are going to go over your 8.3 intro packet.